In the next 10 to 15 minutes, I'm going to explain how to calculate the saturation current for this kind of circuit if the supply current and the diode current is given. And also, we'll see if R1 carries a current equals to Ix by 2 for a given saturation current, how to find out the supply current. Next, we determine the resistance and saturation current for this circuit for the given set of values of supply current and voltages. And next, we'll replace the single diode with two identical diodes and saturation current is given. We'll calculate the voltage across R1 for a given supply current. And also if the resistor carries a current and then saturation current is given, then we'll calculate the resistance value. And finally, in this video, we're gonna plot Vx as a function of Ix for this circuit, assuming the diode follows a constant voltage model and then an exponential model. So let's start with the 25th question. So they say that in the circuit of figure 2.44, we wish D1 to carry a current of 0.5 milliampere and supply current is 1.3 milliampere. We need to determine the required Is. We know that the diode current equation is ID equals to Is exponential Vd by Vt. So Is will be ID exponential of minus Vd by Vt. So ID is 0.5 milliampere and Vd is equals to Vr. Vr is IR into R. IR is Ix minus ID, 1.3 minus 0.5 milli into R value is 1K. So it will be 0.8 volt. So this is 0.8 by 26 into 10 power minus 3. Plugging these values in calculator, we get 0.5 into 10 power minus 3 e power minus 0.8 by 26 into 10 power minus 3. It's 2.16 into 10 power minus 17 ampere. Okay. Next question says, for what value of Ix in figure 2.44 does R1 carry a current equals to Ix by 2? IR1 is Ix by 2 and ID1 will be Ix by 2. To satisfy the KCL, that is Ix equals to IR plus ID, we need to find out the value of Ix, and Is is given as 3 into 10 power minus 16. So Vd is Vr, that is equals to Ix by 2 R, and Vd will be Vt ln Ix by 2 by Is. Okay. So this can be solved iteratively. So let's take an initial value of Vd to be 0.768. That is the diode voltage at barrier potential at 300 Kelvin. So Ix by 2 value will be Vd by R, that is equals to 0.768 by 1K. That will be 0.768 milliampere. Plugging this value here, Vd is Vt ln 0.768 10 power minus 3 by 3 into 10 power minus 16. So 26 into 10 power minus 3 into ln 0.768 into 10 power minus 3 into 10 power minus 16. This is 0.74284 volt. So using this as a new Vd value, we'll calculate Ix by 2 again and solve this iteratively. We'll get Ix by 2 new value and we'll put this value here. So using this as an answer, we'll just iteratively calculate here. So as you calculate that multiple times, you will finally reach a saturated value, that is 0.7419 volt. Okay, we need to calculate Ix. So Vd is 0.7419, that is equals to Ix by 2 into R. So our Ix will be 2Vd by R. That is 2 into 0.7419 by R is 1K. So it is 1.483 milliampere. Okay. Next question says we have received the circuit shown in figure 2.45 and we wish to determine R1 and Is. Measurements indicate that Ix equals to 1 milliampere gives Vx is 1.2 and Ix of 2 milliampere gives Vx as 1.8 volt. We need to calculate the R1 and Is. Okay. So let's write the diode current equation. ID is Is exponential Vd by Vt. Okay. ID is Ix minus IR. That is equal to Is into exponential of Vd will be Vx. Vx is I into R. So IR into R by Vt. Okay. We need to calculate R and Is. Okay. Let's use the measurements they have given. For Ix equals to 1 milliampere, Vx is 1.2 volt. Vx will be Vd as usual. So Ix is 1 milliampere, that is 10 power minus 3 minus IR is VR by R. That is VR is 1.2 by R. That is equal to Is exponential of Vd is Vx. It's 1.2 by Vt. And for the next set of values, Ix equals to 2 milliampere, which gives Vx as 1.8 volt. So it is 2 into 10 power minus 3 minus 1.8 by R equals Is exponential of 1.8 by Vt. Let's do equation 2 by equation 1. We get exponential of 1.8 minus 1.2 by Vt equals to 2 into 10 power minus 3 minus 1.8 by R by 10 power minus 3 minus 1.2 by R. Let's calculate. E power 0.6 by 26 into 10 power minus 3. Is 1.05 into 10 power 10. Okay, now separating these equations, let's take this as A. So it will be A 10 power minus 3 minus A 1.2 by R equals to 2 into 10 power minus 3 minus 1.8 by R. So it will be A into 10 power minus 3 minus 2 into 10 power minus 3 equals to 1 by R of A into 1.2 minus 1.8. We can write R as A into 1.2 minus 1.8 by A into 10 power minus 3 minus 2 into 10 power minus 3, where A is our answer. So answer into 1.2 minus 1.8 by answer into 10 power minus 3 minus 2 into 10 power minus 3. So it is 1200 ohms. Okay, we have calculated R1. We need to calculate Is. So let us use the first set of values. For Ix equals to 1 milliampere, we get Vx as 1.2 volt. So 10 power minus 3 minus 1.2 by 1200 equals to Is exponential of 1.2 by Vt. Okay. 10 power minus 3 minus 1.2 by 1200 is 0. That is true because Is goes to, it's almost 0, saturation current is almost 0. Let's use another set of values to find out the Is. It is 2 into 10 power minus 3 minus 1.8 by 1200. equals to Is exponential of 1.8 by Vt. 2 into 10 power minus 3 minus 1.8 by 1200 equals to 1 by 2000 into e power minus 1.8 by 26 into 10 power minus 3. So Is is equals to 4.289 into 10 power minus 34. This is so small so that it is equated to 0 as in the first case. We have seen that. Okay. Now let's go to the next question. So the circuit illustrated in figure 2.46 employs two identical diodes with Is as 5 into 10 power minus 16 ampere. We need to calculate the voltage across R1 for Ix equals to 2 milliampere. Okay, we need to calculate the voltage across R1. So that is VR1 equals to, it is basically Vd plus Vd. It's two identical diodes. So 2 times Vd, and diode equation will be Vt ln Id by Is. We don't know about Id, so we can write that as 2 Vd ln Id as Ix minus Ir by Is, and that will be 2 Vt ln Ix minus Ir as Vr by R by Is. R value is given, we need to find out R. So basically we have to do this iteratively. So let's assume Vd as 0.8 volt initial value. So Vr will be 1.6 volt. Okay. Now let's plug that value in this and we get 2 into 26 into 10 power minus 3 into ln Ix is 2 milliampere. So initial value of VR will be 1.6. R is 2000. Ix is 5 into 10 power minus 16. So it's 1.428. Now take this as the updated value and plug this here. If you calculate it multiple times, we get VR1 as 1.484 volt. So the voltage across the R1 is 1.484 volt. Okay, let's go to the next question. They say that in the circuit of figure 2.47, determine the value of R1 such that the resistor carries 0.5 milliampere and the saturation current is 5 into 10 power minus 16 ampere. Okay, we need to calculate value of R1. So the value of R1 can be given by voltage across R1 by current through R1, that is equals to voltage across R1 will be 2 Vd by IR1, 2 by IR1 into voltage across diode will be Vt ln diode current by saturation current. So it will be 2 by IR1 is 0.5 into 10 power minus 3 into 26 into 10 power minus 3 ln diode current will be 0.5 milliampere by saturation will be minus 5 into 10 power minus 16. Let's calculate this. Yeah, so it is 2873 ohms. Okay. Now let's close this video with this final question. So they say that sketch Vx as a function of Ix for the circuit given in figure 4.2.48, assuming a constant voltage model and an exponential model. Okay. First of all, we need to write the current equation as a function of Vx. Let's write the diode current equation. Okay, diode will be on only when Vx is greater than Vd. So assume the diode is off. Then Vx is Ix Rx. Okay. When it is on, Vx is Vd. So the plot will be this is Vd on. So until Vx is less than Vd on, Vx equals to Ix Rx. That means it follows a straight line passing through origin. And then it will be Vd. Yeah. So this is the function of Vx against Ix for a constant voltage model. Now let us see the exponential model. When Vx is greater than Vd, it will be on. Vx is less than Vd, it will be off. So during off, it will be Vx equals to Ix R1. When it is on, voltage across diode will be Vt ln Id by Is. So Id will be I minus Ix minus Ir. Vx will be Vt ln Ix minus Ir by Is. Okay. So Ix minus Ir will be Is exponential of Vx by Vt. So Ix equals to Is exponential Vx by Vt plus Ir. So basically when the diode is turned on, the current through diode will be almost zero. So we will be left out with Ix equals to Is exponential of Vx by Vt. So the plot will be something like this. Until Vd on, it will be straight line. And then it explodes. Sorry, I need to write the other way. It is Vx equals to Vt ln Ix by Is, because the cause and effect are given on the graph. We'll follow the ln graph. Okay, cool. So that's it for today, and we have completed this chapter. We'll do some more problems in the upcoming videos, and we'll start a new playlist of the new chapter called diode circuits. Yeah, meet you there. Bye.